What I want to do in this video is hopefully give more intuition as to why the binomial theorem or the binomial formula involves combinatorics. So let's just think about what this expansion would be. So I'm just using a particular example that's pretty simple, x plus y to the third power, which is x plus y times x plus y times x plus y. So we already know what the terms look like. We could pick an x from each of these. So if we pick exactly an x from each of these, that's going to be our x to the third term. And it's going to be, and we essentially picked no y's then, because we picked an x from each of these when we multiplied out to get this term. And how many ways are there to construct that? How many ways are there if we're picking from three things? So we're picking from three things. How many ways can we choose exactly 0 y's of not picking a y? Well, there's only one way to do that. There's only one possible way of doing that, by taking by not picking a y from each of them, or you could say by picking an x from each of them. So the coefficient right over here is 1 x to the third. There's only one way. When you take this product out, only one of the terms initially is going to have an x to the third in it. Now, what about the next term? So plus. So what if we're going to pick from 3 buckets, but we want to pick one y. So another way of thinking about it, you have 3 people, or we have 3 people, this person, and this person, and one of them you're going to choose to be be your friend. That's another way of saying which of these are you going to pick the y from. So this is the exact same thing as the combinatorics problem of from three things, you are choosing one of them to be y. And of course, 3 choose 1, this is equal to 3. And so if you're picking one y, that means you're picking 2 x's. So, and you're taking the product of everything. So it's x squared times y to the 1. And we could keep doing that logic. So plus, so now we're going to think about the situation where we are picking 2 y's out of 3 things. So it's x to the first, y squared. So we're starting with 3 things, and we're going to pick 2 of these y's. So it could be this y and this y to take the product to construct the product y squared. So it could be y times that x, or it could be y times that x, or it could be y times x times y. So this is 3 choose 2. So out of 3 things, what are the different ways, what are the combinations of picking 2 things? If you have 3 friends, how many combinations can you put 2 of them in your 2-seater car where you don't care about who sits in which seat? You're just thinking about how many different combinations can you pick from that. And once again, this evaluates to 3. And then finally, how many different ways from a set of 3 things, from 3 different things, so from each of these expressions, how many ways can you pick exactly 3 y's? Well, there's only one way to do it. You pick this y, and that y. And so if you're picking 3 y's, that means you picked 0 x's, and you have picked 3 y's. So that's why we're dealing with combinatorics here. 3 choose 3. From 3 expressions, your 3 binomials right over here that you are taking the product from, you're choosing. You need to choose 3 y's. So you have to pick the second term in all of them. There's only one way to do that. Here, you want to pick the second term, the y term, in 2 of them, exactly 2 of them. Here, you want to pick the y term in exactly 1 of them. There's one way to do this, 3 ways to do this. Sorry, there's 3 ways to do this, 3 ways to do this, 1 way to do that, 1 way to do that. So this is 1, and this is 3. When you apply the formula for 3 choose, or n choose k, 3, and this is 1.